Hello. Welcome to the OAME 2025 virtual conference. Thank you for joining us. My name is Taras Gula, and I'll be with you on this virtual setting for the next 20 minutes or so. Although the workshop will be an hour, this is just kind of some of the information that will hopefully spur good conversation and workshop feeling. The OAME 2025 Organizing Committee acknowledges the land and people of the Mississaugas of Scugog Island First Nation. We are thankful to be welcomed on these lands in friendship. The lands we are situated on are covered under the Williams Treaties and the traditional territory of the Mississaugas, a branch of the Greater Anishinaabeg Nation, including Algonquin, Ojibwe, Odawa, Potawatomi. These lands remain home to a number of indigenous nations and peoples. Okay. We acknowledge this land out of respect for indigenous nations who have cared for Turtle Island from before the arrival of settler peoples until this day. We also acknowledge that as a community we have much to do in order to right the many wrongs that have tainted these lands and our relationships with the indigenous peoples who call them home. Collectively, this history connects all of us. We are all affected in different ways, but we owe it to future generations to reflect, learn from the past, and move forward as allies, as friends. Please take a moment to reflect upon the land upon which you are attending this session today. And as you reflect on it, I wanted to put up an image of Treaty 13 territory where I'm recording this session right now and where I grew up. What you'll notice in this image, or this set of images, is that you have the Don River to your right, I'm pointing to my left, and the Humber River to your right, forming the east and west boundaries of Treaty 13. I started looking into this because I was at a conference where we had an international attendee who said, what's in these two what are in these treaties that you keep mentioning? And I said to myself, or asked myself, I don't know. And so I looked into it, and that's one of the things that I found out recently, that these were the bounds of the original treaty. Now, the more formal presentation. Numeracy tasks as distinct from mathematics tasks. Our responsibility. I won't get into our responsibility as much, but it'll be a thread that unites it, because I think acknowledging the difference, just like doing land acknowledgement, is in some ways the beginning steps towards taking responsibility for bringing changes. A useful metaphor when thinking about education. Anna Svard, thick book, and within it, it's a fascinating book, lots to think about, and where we also discover that thinking is an individualized form of the activity of communication. So it's a different perspective on thinking. It's not about passing on information. And so I think she juxtaposes the communication metaphor for thinking, and a lot of education where we're passing on information from the teacher to the student in some way. To know X is to become a participant in a discourse, the discourse of X. So to know mathematics is to become a participant in the discourse of mathematics. To know literature, to become a discourse in the participation in a discourse of literature, and same with hockey. To do that effectively, there are many different things that need to be done. But essentially, that is her kind of conclusion, or what she's pitching to us in a way of speaking. And success in that means entering into that participation and entering into the participation in the discourse. Teaching then is the act of bringing a student into the particular discourse. So as a mathematics teacher, we bring students into the discourse of mathematics. Very useful metaphor. Mathematics discourse is about mathematical objects, structures, and their relations. Can 1 + 1 equal what looks like 10? Well, when we think of it as 10 objects, this is nonsense. But in base 2, this makes sense. So somebody who's in the mathematics discourse thinks about how can it be that visual representation 1, 0, can that be somehow mathematically sound? And it can be. Whereas 9 + 1 = 91 doesn't make sense in mathematics discourse unless we bring in some different kind of operation instead of addition. And Jennifer Shidlick came up with a mathematics sophistication index in which this was one of the questions that she found mathematicians united on the solution. 5 in the first blank, 7 in the second blank, whereas many other people would put in 7 in the first blank and 9 in the second blank. And it's different perceptions of the equal sign. And opening that conversation up in a classroom, I think, is very, especially in a college setting, high school setting, probably too, could be very useful. And then making sure that from an elementary setting that at least students have been experiencing that and kind of thinking about what the equal sign means, I think is some way bringing students into mathematics discourse. Fascinating conversations I had with college students about that. So to bring students into mathematical discourse, here's an exercise that Anna Svard presents in her book. And the key part of this, so again, is functions. We have a table of values. We have different functions that can generate the same table of values. And you kind of go, who's right? Which one is right? Are they all right? Are they different? Are they one better than the other? And so I think that's an important, that's something that we don't tend to do. We don't have conversations about different representations and which ones are better and worse, or are they all equal? And that's a way of bringing students into mathematical discourse. Numeracy discourse is very different. It's not about mathematics. It's not even in the same ballpark. And that's something that Miroslav Lovric and myself spent quite a few years until we got there, kind of. It's about math education. And we kind of know the history. The history is, it comes from the concern about transfer from school math to the real world. That what you learn in the classroom, then students go out and they can't make change in a store, working in a store when the numbers are a little bit off or something, not normal, or they don't have a calculator with them. So that's kind of a standard perception of what numeracy comes from. But the idea of transfer, and I've added a few caveats there, abstract and procedural to concrete, and also the idea of thinking spaces. So moving from the shifting from thinking spaces, I think, is a little bit something that broadens that. So rather than just thinking about the classroom to the real world, we're talking about the thinking spaces. Numeracy discourse, one area of consensus. We have an orientation towards the concrete over the abstract. And by the way, numeracy, we're including quantitative reasoning, mathematical literacy, quantitative literacy. There's a whole wide range of titles for the same idea and the same struggle in math education. So orientation towards concrete over abstract in numeracy discourse, social justice issues, connected a little bit to the concrete over the abstract. We value the mathematics that are done in an informal setting, not just a formal setting. And also the idea of bringing the power of mathematics to those outside the study of formal mathematics. And so that's, again, fits in perfectly with the college math setting. Mathematical thinking is possible without the necessity for deep and broad knowledge of mathematical objects and structures. You don't have to be a mathematician to participate in mathematical thinking. Resistance to math light, so seeing a reduction of numeracy to, as long as they can multiply, they'll be fine. And so the focus on multiplying, addition, and just the basic operations is not necessarily going to produce somebody who is quote unquote numerate. Post-structuralist perspective, again, the idea that through a numeracy perspective, you do not see the world as structured mathematically, whereas many, not all mathematicians do or may. The nillus problem. The nillus problem is, this is straight from a high school, grade 11 high school from, he just finished university, so that maybe was 5 years ago, 5 or 6 years ago, grade 11 Toronto High School. And this is a test question in the quadratics unit, and thinking, inquiry, problem solving. He solved the problem, but he didn't solve it using parabolas, and so he got a 1 out of 6. And so what's this question about? It's confusing. It's really difficult. The more you think about it, the more you're like, I really don't know what this teacher wanted, except obviously wanted Danilo to do to solve the problem using the quadratic function or parabolas, and he did not. And so 1 to 6. So do we value that response or do we not? Here's a way out. And again, so Miroslav and I kind of came to the idea that numeracy tasks are a distinct form of or a distinct from mathematics tasks. Dahl et al. Went a step further. They found 3 types of tasks. Tasks that are internal to mathematics. So the 1 + 1 = 10. The Shidlick's mathematics sophistication, that one with the equal sign, those are all internal to mathematics. So they're about mathematics discourse. Then we have 2 other types of problems. One is internal to mathematics set in a concrete real world. The nillus problem would be, I think at this point, I would qualify it as a poor attempt at the second. And then the third, external to mathematics, it's set in the concrete real world context. The biggest difficulty we have, I think, generally speaking, is we confuse the latter 2. We're pretty clear on the internal to mathematics tasks. Those are pretty straightforward. We confuse the ones that are internal to mathematics and ones that are external. We kind of lump them in together as a system, not we individually, but we as a system. Examples of each type of task. So I'm going to give you a minute to read these over and then try to match them up with these 3. Internal to mathematics, purely abstract, internal to mathematics with concrete, or external to mathematics. Then I'm going to drop down the answers. So we see the first one, the spherical snowball doesn't exist in the real world. It's really it's a calculus problem. So it's internal to mathematics, but it's set in the world of snow. Polya's problem is from his famous book on problem solving. It's internal to mathematics. It's set in the abstract. He talked about another set of problems he called practical mathematics. And so that would be akin to numeracy tasks that we're calling numeracy tasks, or external, internal, with a concrete setting. And so Snowball 2, so we reframed the first one as one that would be external to mathematics. But when you're reading it, I'm sure you're thinking, well, this is more like a science class rather than a math class. Excuse me for the cough, by the way. I'm coming off a cold. Numeracy tasks, then, are meant to be external to mathematics using Dahl et al.'s perspective. They are set in concrete contexts and are about that context. They are about, so that's the key thing, the aboutness. They provoke transfer, the shifting between concrete, real world, and abstract mathematical thinking spaces. And they also are referred to, and so I've mentioned that already, quantitative reasoning, quantitative literacy, mathematizing. That's within the world of numeracy discourse. But then in the mathematics and mathematics education discourse, we also see mathematical modeling, word problems, And we see that in the Ontario curriculum. Those of you that have paid attention, in the previous curriculum, we had numeracy appeared and numeracy has disappeared, and it's been replaced, not nicely, not elegantly, in any stretch of the imagination, with mathematical modeling. And you can see that within the Ontario curriculum, mathematical modeling is lumped in under, right? So it's under a mathematical structure. So rather than being external to mathematics, it's still very much internal to mathematics. And numeracy tasks do not need to be called numeracy tasks. So they can be called mathematical modeling tasks. And we see here the same shifting between thinking spaces, transfer that we talked about earlier, that I mentioned earlier. You see that here with mathematical modeling, an image of mathematical modeling, where we have the mathematics, the abstract world, on your right, and the rest of the world, the practical world, the concrete world, on your left. And you can see how the shifting goes between one and the other, and we kind of go back and forth. And I think this is the model. We've looked at quite a few of them, and they're in our papers, that show more or less the same thing. This one really nicely crystallized the two separate thinking spaces, though the word thinking spaces is not theirs. And you can think of it as discourses, Where did we go with this? Where we went with this is we came up with a kind of a setting or a description of what would be a high quality numeracy task, and we ended up with a rubric for numeracy tasks, not for numeracy behavior. So we're not focusing on the student here, we're focusing on the teacher and what the teacher can do with what they have in front of them. And we've heard back from a few people already that have run their own tasks, problems through this, and have found surprising and a little bit nerve-wracking, including myself. Nerve-wracking tasks that I thought were really good tasks did not do well in a numeracy setting. And so we believe our responsibility at this point is, we're not necessarily advocating, and I'm not advocating, that every task needs to be a numeracy task, needs to pass this rubric and be high quality in this way. But this rubric is very useful for kind of saying, aha, what am I doing here? Would I be successful in the task that I'm giving, so I understand what it is asking the students to do? And what is it challenging? What kind of thinking is it challenging with the students? And so therefore, when we're presenting tasks to students, we're like, okay, is this a mathematics task? Is it external to mathematics? Which is it? And I think that's an important thing to do. In the college setting, I think that's really important. But I think in the high school setting as well, when we give them those kind of fake, and I'm a former high school teacher, when we give them those fake problems, those fake real world problems that we all love and hate, we can at least tell students, this one is not about the CD sales. This one, you're not really helping this person sell CD sales. You're trying to see how this mathematical model works in this setting, that it can be used to model various kinds of settings. And so I think that's the usefulness of it. So we can then frame the questions differently. So Danilo's problem, so rather than framing the question or setting up the setup of the question, could be use a quadratic formula to solve this. I'm going to stop here. In the workshop, I hope that we have it. I look forward to having a chance, trying some tasks out, hearing back from the participants, and having a wonderful experience. And I hope this you'll find useful. You can see a little bit more about the rubric, and the references are all in the papers, which are also the links available through the rubric. Thank you for your time. Have a great conference. Bye-bye.